The three p orbitals are labeled px, py, and pz because each one is aligned along a different axis in space, and they are mutually perpendicular to one another. Think of p orbitals like three dumbbells centered on the same atom but pointing in three different directions. One along the x-axis, one along the y-axis, and one along the z-axis. Each orbital has the same shape and energy for an isolated atom, but they point in different directions. So electrons in one orbital spend their time in different regions of space than electrons in another. Scientists label them px, py, and pz to keep track of which direction each dumbbell points. And this matters because chemical bonds form when these orbitals overlap with orbitals from other atoms. If an orbital points the right way toward another atom, it can overlap and make a strong bond. If it points elsewhere, the overlap and bonding will be weaker or different. A common mistake is thinking the labels mean the orbitals are different shapes or energies for the same atom, when in fact they are the same shape and usually the same energy, but just oriented differently, and the simple fix is to remember they are directional copies of the same orbital. Another error is assuming the axes labels are absolute in space rather than relative to the molecule. So remind yourself that chemists choose axes to make drawing and predicting bonds easier. People also sometimes ignore how orientation affects bonding and predict bonds purely from count. And the tip there is to sketch orbital directions to see if overlap is possible. You can visit www.gumballdegree.com to find more videos and resources on this topic.